Observability and SRE Part 14. This episode has 13 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Current market 2026. Terraform state at scale. With hundreds of Terraform workspaces, how do you prevent state drift, blast radius, and slow applies as the platform scales past 50 GCP projects? Here's a strong way to approach it. Split state into small, purpose-scoped workspaces, per project, per environment, per logical component rather than one giant state file. So blast radius from any single apply is naturally limited and applies stay fast since each workspace has fewer resources to plan against. Run scheduled drift detection jobs. Terraform plan in CI on a cadence, alerting on unexpected diffs across all workspaces so manual console changes are caught quickly. And use a consistent module structure with remote state data sources for cross-workspace references instead of manually copying values between workspaces. Nice. Let's continue. Question 2. Platform team structure. How would you structure a platform engineering team? And what ratio of platform engineers to product teams would you target as the org scales? Here's a strong way to approach it. Structure around clear domains, infrastructure or networking, developer experience or golden paths, observability, security tooling, with each subteam owning a specific part of the platform rather than one undifferentiated team trying to do everything. A commonly cited starting ratio is roughly 1 platform engineer per 8-12 product engineers, but the right ratio depends heavily on how much self-service automation exists. A more mature, automated platform can support a higher ratio since the team isn't doing manual work per request. Great. Moving on. Question 3. You build it, you run it. How would a platform team enable you build it, you run it ownership without every team reinventing observability, security, and deployment tooling? Here's a strong way to approach it. Provide golden path templates that bake in observability, security controls, and deployment pipelines by default, so teams get production-grade tooling automatically when they use the platform rather than having to build it themselves. The platform team's job is to make the golden path the easiest option, not to mandate it. If opting out is harder than opting in, most teams will naturally consolidate on shared tooling instead of reinventing it. Alright, next question. Question 4. Platform cost visibility. How would you give product teams self-service visibility into their own infrastructure cost inside the developer platform, without building a full FinOps tool from scratch? Here's a strong way to approach it. Enforce cost allocation labels via policy so every resource is attributable to a team, and surface that data through existing tools rather than building new ones. A Looker Studio dashboard or a simple query against the billing export exposed in the internal developer portal. Updated daily. Start with visibility. Teams see their own spend trend before adding budgets or enforcement, since visibility alone often drives meaningful behavior change without needing a full FinOps platform. Let's keep going. Question 5. Golden Path versioning. A golden path template changes and existing services are now out of date. How would you roll out the update and measure adoption without breaking running services? Here's a strong way to approach it. Version the golden path template explicitly, like a package version, so existing services stay pinned to their current version and are not silently broken by an update, and provide a clear, documented upgrade path for teams to opt into the new version on their own schedule. Track adoption via the version each service is running, surfaced in the service catalog, and proactively reach out to teams still on old versions if the update fixes something important like a security issue. On to the next one. Question 6. Platform onboarding. What would the first day experience look like for a new engineer using your internal developer platform to ship their first service to production? Here's a strong way to approach it. The engineer should be able to scaffold a new service from a golden path template with one command or a self-service UI, get a working CI or CD pipeline, observability, and a staging environment automatically, and deploy to production within their first day or two without filing a single infrastructure ticket. The experience should feel like the platform is doing the undifferentiated heavy lifting so the engineer's first contribution can be actual application logic, not YAML plumbing. Good. Here's another one. Question 7. Platform team KPIs. What metrics would convince leadership to keep funding a platform engineering team versus letting application teams manage their own infrastructure? Here's a strong way to approach it. Track metrics that tie platform investment to business outcomes. Time from idea to production deployment. Percentage of infrastructure requests self-served versus ticket-driven. Incident frequency or MTTR trend across teams using the platform versus those that aren't. And total engineering time saved by not duplicating infrastructure work per team. Frame these as the counterfactual cost of not having the platform. What it would cost if every team rebuilt this capability independently, since that's the comparison leadership actually cares about. Nice. Let's continue. Question 8. Platform API design. How would you version a platform self-service API so existing automation doesn't break when you add new capabilities? Here's a strong way to approach it. Use explicit API versioning, URL path or header based, so breaking changes only affect consumers who opt into the new version, and prefer additive, backward compatible changes, new optional fields, new endpoints, over modifying existing contracts whenever possible. Maintain a deprecation policy with a clear timeline and communication process for any version you do need to retire, and provide a way for consumers to discover which version they're on and what's changing before it affects them. Great. Moving on. Question 9. Linux CPU utilization. How would you check CPU utilization on a Linux server, and which commands would you use? Here's a strong way to approach it. Use top for a live, continuously updating view of per process and overall CPU usage. Mstat, from systat, for per core breakdown and historical averages, and mstat1 to see CPU usage alongside run queue length and context switches over time. For a quick one-off snapshot, uptime shows load average and PSOC sort equals % CPU head lists the top CPU consuming processes. Alright, next question. Question 10. Linux memory usage. What commands would you use to check memory usage on a Linux server? Here's a strong way to approach it. Use FreeH for a quick human-readable summary of total, used, free, and available memory. Available is the more meaningful number since it accounts for reclaimable cache. Top for per process memory usage. And cat or proc or meminfo for detailed kernel-level memory statistics. PSOC sort equals % memhead quickly lists the top memory-consuming processes when hunting for a specific culprit. Let's keep going. Question 11. High CPU troubleshooting. How would you troubleshoot a Linux server with high CPU usage? Step by step? Here's a strong way to approach it. Start with top to identify which specific process is consuming CPU, then check whether it's genuinely working, expected load, or stock, a runaway loop, deadlock, using strace P,